Okay, matrix, in this lesson we're going to be focusing on a fascinating theorem called the similarity theorem. We're going to be focusing on similarity of triangles. If two triangles are similar, we use the symbol 3 vertical lines to indicate this. We actually would say that triangle ABC is similar to triangle DEF. That's the notation we use. But what does this mean, that two triangles are similar? Well, if we go back to earlier years, if you remember, triangle ABC, if you enlarge it, you get triangle DEF. And what's the important thing is that these two triangles have the same shape, but not necessarily the same size. DEF is an enlargement of AB. So, for example, if AB was 2 units or centimeters, we can double it and get 4 for DE. BC might well be 3, so that becomes 6. And AC might be 4, so that becomes 8. And you've really just enlarged. They call that a scale factor enlargement of 2. So really, DEF is an enlargement of ABC. Now, what is important with similar triangles, and this is the important thing, if two triangles are similar, now watch this, if ABC is similar to triangle DEF, there are two things that hold. The one is that the angles, the interior angles, the corresponding angles are actually equal. Now look at that. Angle A is equal to angle D, B is equal to E, and at the same time C is equal to F. Okay, but there's something else that holds true with these triangles that are similar. If you look at the ratios, if you take AB over DE, if you look at AB over DE, that's 2 over 4, which is a half. What is BC over EF? BC over EF is 3 over 6, which once again is a half. And then what about AC over DF? Look at that. AC over DF is actually, let's go and check that, AC over DF is 4 over 8. And what do we notice? That that's a half. So if the triangles are similar, we can say that the ratio of AB to DE is equal to BC divided by EF is equal to AC over DF. Remember that these each separate lengths, A, B, D, E, they're not necessarily the same. They actually differ in length. As you can see, they all differ. All the sides differ. But if you divide them and create a proportion or a ratio, you'll notice that all of these guys, AB over DE, BC over EF, and AC over DF, are pretty much the same. They all equal a half. So if triangles are similar, what we do know is that they call it the corresponding sides. The corresponding sides are in the same proportion, okay, or ratio, if you like, there. And then the other thing, if triangles are similar, that's the key thing. If triangles are similar, the corresponding angles are equal. They call that equiangular. Okay, so if the triangles are similar, then we get the equiangular triangles. The corresponding angles are equal, and also the corresponding sides are in the same proportion. Now, it also works the other way. Now this is important, if the triangles are equiangular, in other words, if angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to F, if the corresponding angles are equal of the triangles, if these angles are equal, then we can say, then the triangle ABC is similar to triangle DEF. That's one condition. So if equiangular, we can conclude that the triangles are similar. And also, if you get the ratios, if you get AB over DE equaling BC over EF equals AC, if that holds true, then you can also say that then the triangle ABC is similar to triangle DEF. So there's two things. So the important thing here is if the triangles are equiangular, their corresponding angles are equal, then the triangle ABC is similar to DEF. And if the corresponding sides are in the same proportion, then the triangles are similar. But remember, if triangle ABC is similar to triangle DEF, then that holds true and this holds true. Okay, but to prove triangles similar, you'd want to prove either equiangular, that the corresponding angles are equal, or that the corresponding sides are in the same proportion. That would then prove similarity of triangles. But if the triangles are similar, then the equiangular and the corresponding sides in the same proportion holds true. So that's the important thing that we're going to explore as we proceed with this. And by the way, just something about the triangles being similar. If you look at this here, if you take that, you create what I call a little frog face. Now, if you have a look at this, if we go to this thing here, if you have a look at triangle ABC and triangle DEF, if you focus on those, we can create a little frog face which helps us here. And this is, I'm going to do it in green. You've got an eyebrow, AB divided by DE is BC over EF. BC over EF is AC over DF. And notice there's my little froggy saying, hello guys, how are you? And that, once you get the frog face, you can create those ratios over there. AB over DE, AB over a DE, that's your first eyebrow. Then you've got your second eyebrow is BC over EF, and then you've got your mouth, which is AC over DF, and that helps a lot. So if the triangles are similar, you can create the ratios. In other words, the corresponding sides are in the same proportion, so you get that. Or you can also, if the triangles are similar, you can have the corresponding angles being equal there. Okay, let's look at an example where we put this all together now. Have a look at this. Now, if you focus on this, we've got to prove that triangle ABC is similar. ABC is similar to DEF, and you'll notice that we're given some angles here. Okay, now also, after we've proved similarity, we then want to jump to the fact that the corresponding sides are in the same proportion. So to do that, let's work with angles. So we've got to prove that the triangles are equiangular. Now watch this. This is important. If angle A, if you look at this, you've got triangle ABC and triangle DEF. Now let's work with the corresponding angles. Angle A and angle D. Look at that. Angle A and angle D are both equal to 30. That's given. Then we've got, if you think of it, angle B and angle E are equal. Angle B is equal to angle E there because they're both 130. So B and E are equal. But now, listen. If A is 30 and B is 130, these two add up to 160. So what do you know about angle C? It must be 20 because 30 plus 20 is 50 and 50 plus 130 is 180. Now here it works as well. If that's 30 and 130, that angle is 20 degrees, angle F. So C is equal to F there as well. So the corresponding angles are equal. Angle A is D, angle B is equal to angle E, and angle C is equal to angle F. The corresponding angles are equal. Now these two are given, but this guy, the C equal to F, comes from the fact that the sum of the angles of a triangle add up to 180. So if that's 30 and 130, which is 160, C is forced to be 20 by the sum of the angles of a triangle. And likewise in the enlargement here of triangle ABC, if that's 30 and that's 130, that F is forced to be 20. So if you can prove that angle A is D and B is E, then C equals F from the sum of the angles of a triangle. So let's construct a proof here to establish the fact that the triangles are equiangular, and then we can prove similarity. So we can say in triangle ABC and triangle DEF, what do we know? Well, the first thing we know, if you think about it carefully, is number one, we know that angle A is equal to angle D is equal to 30 degrees. That is given to us. The second thing is that B is equal to E is equal to 130 degrees. That is also given. So what's your conclusion about the third pair of angles? Angle C is equal to angle F must be 20, and that's from the sum of the angles of a triangle. And then, of course, if the three pairs of angles are the corresponding angles are equal, we can say therefore triangle ABC is similar to triangle DEF, and the reason, if you've got three pairs of corresponding angles equal. So there's your A part of the question. What does the B part say? we'll create the ratios. Can you prove that those ratios are true? We'll have a look at this. If we do a little frog face, where's my green? Here we go. AB over DE, BC over EF, AC over DF. So we can immediately get that there. We can say AB over DE is equal to BC over EF is equal to AC over DF, and that's because the triangles are similar, and because they're similar, the sides, the corresponding sides, are in the same proportion. And there you've got it. Now, in the practice example, guys, what I'm going to do is I'm going to give you the corresponding sides. I'm going to give you the lengths of the sides, and I'm going to say prove that the triangles are similar. So you're not going to work with angles here. And then once the triangles are similar, we could talk about angles.